Hi, this is Jay Tedeschi, Technical Marketing Specialist at Autodesk, and today we're going to take a look at the use of the frictionless constraint in Inventor simulation to essentially enforce symmetry in a part. Now, as you can see, we used a cut plane in this multi-body component to slice the piece literally right down the middle, symmetric slice. Now, it's important that the slice be symmetric. What we do now, once we have these cut faces, is add the frictionless constraint to those faces. And essentially what it does is it allows us to create an input model. So if you look at the number of nodes and number of elements that we have to create, it's half as much as we would have to create if we were doing a simulation for the entire part. So by splitting the part down the middle and adding that frictionless constraint to those cut faces, we've essentially told Inventor simulation that this is in effect that it should simulate those stresses across the entire part. So it allows you to carry out your analyses in half the time that it normally would take, because essentially we're using half the number of elements and nodes. So the the input deck itself is much smaller that has to be solved. So now we get down here to the automatic contact detection. We've added our frictionless constraint, our pin constraint, as well as a fixed constraint, which would be where this lever would attach to the bucket. And now it's just a matter of setting characteristics for the mesh itself. Now these relate to the size of the mesh and exactly how fine versus coarse we want to go relative to the speed of the analysis itself. It's a relatively small part, which I selected specifically because it would solve quickly during this video. So here we have our results overlaid on the part, and you'll notice that we have no spikes in stresses at the cut faces, which we would get if we had split those faces and then added, for example, a fixed constraint. So because the part believes that it's giving us results for a full part instead of just the half part, we're looking at totally accurate results for the entire part itself. So that's a quick look at frictionless constraint in Inventor simulation. I hope this helped. Talk to you later.